So let's start your June 23. Question 1 says that we have a function g of x. G of x, show that g of x equals to 0 has a root alpha in the interval 3 is to 4, right? Or 3 and 4. This is what exactly in every numerical method question you will see. And I just have to find out that if the value for g at g3 is negative and then g4 is positive. That means obviously there is a change in sign between 3 and 4 where gx is a continuous value. Therefore, obviously the root or the value for alpha or gx equals to 0 must lie within the interval of 3 and 4. Right? That's what every time you just have to say. If you calculate g3, that's going to be x power 6 2x 1000. 3 power 6 2 3 3 power 6 to 3 minus 1000. I'm going to get negative 265. So our G3 is negative, and then again calculate G4. That's going to be 4 power 6 to 4 minus 1000. Right, so we have your 4 power 6 to 4 minus 1000, that's 3104. So I can obviously understand that here the value for your g3 and between the value for your g3 and g4 there is a change in sign where obviously gx is continuous and obviously the root must lie within the interval of 3 and 4. So I'm going to write that there is a change in sign within 3 and 4, right? For every question the answer is always going to be same. And after this, if I write, they are giving you that the iteration formula is this, where x1 is 3. First, to 4 decimal places, calculate x2. 1000 minus 2x power n. For part B1, I want to find out x1 plus 1. That's basically x2, which is going to give you 1000 minus 2. X1 was 3, so we have your x power 1 here. So that's going to be 3, and everything inside root of 6. 1023, then we get 3.1591 according to 4 decimal places. That's 3.1591. And after this, now they're asking you to find out the value for your alpha using the repetitive process. So repetitive iteration. Repetitive iteration means I have to continue this value for x until I get the same value again and again and again. So in that case, I have to calculate the value for your x3 then. So that's 2 plus 1, which is going to be x3. And this one is going to be 1000 minus 2, 3.1591. And everything under that, cube root of 6. So you get 3.1591, that is 3.1589. And then again after this, x3 plus 1, that is x4, which is 1000, 2.3.1589. And this one's again going to be power of 6, which is 3.1589. 89, that is 3.1589 again. This is your repetitive process, right? After this, I got the same answer twice. Even if I continue with this, I'm going to get the same answer again and again. 3.1589. That means this is the value for your alpha. 3.1589. That's the correct answer over here. Is this clear, Tamit?
Yes, ma'am.
Okay, so we are done with this question 1 then. If I move on to your question 2, there we have seen that log 6 t and log 6x. And we have a graph for this, and the graph intersects at y-axis and x-axis. Shows a linear relationship for t and x, and the graph passes through the points, these values. Find an equation for this and this. I mean, this is just y is equals to what? Um, y equals to mx plus c. I can write down the equation is. This is a downsloping line. I can obviously find out the gradient. That's going to be 0 minus one y-axis is 4 minus 0, and your x-axis was 0 minus 2, right? So it's going to be minus 2 here. The gradient is minus 2. So now I can just create the equation directly, that y equals to mx plus c. The value for your y is log 6t, m is minus 2, x is again log 6x plus 4, right? Y-intercept was 4. So this is just the equation. And after this, they're asking you that hence find the exact value of t when x is equals to 216. That means you have inserted the value for x over here. So you get your t as, if I to take this 6 to the right hand side, it's going to be 6 minus 2 log 6, 216 plus 4, right? Everything will be the power of 6. That will eliminate the x, and we can easily put this in the value for your 6. So you get 6 power minus 2 log 6, 216 plus 4, and we're going to get 1 over 36. That is your value. So you get the value for your t as 1 by 36. And after this, now they're asking that find an equation not involving logs linking x and t. I mean, now that I know that t is this much, what? T is your 2 log 60 plus 4. Six minus 2 log 6t, so 6x plus 4. I can obviously consider writing this as 6 power minus 2 log 6x, and then plus means obviously this was multiplied with that 6 power 4, right? And this again in the negative place, obviously it means this obviously belongs to the denominator. So we can write this 6 power 4 divided by 6 log 6x square. Just 1 minute. So now after this, we have in the base as 6 log 6x square, right? For this kind of situations, 6 log 6 x square can be written as this part actually. 6 log 6 can be written as 1, because you can take this as a power of 6. I mean you can introduce this as a log again. So you can write this as x square. Sorry, 1 minute. 6 log base 6 x square, and then this 6 and log 6 are going to cancel each other out. That will give you the value for 1, leaving only the value for your x square. So in the denominator, 6 log 6, that gives you the value for 1 and giving leaving only x power 2. So all this time this equation was equals to t, right? So finally, you can write that t is equals to 6 power 4 divided by x square. And that 6 log 6 will cancel each other out. I mean, you just get 1 out of that, nothing else. Is this clear, Tamid?
Yeah, ma'am.
Then after this is the equation for t in terms of x. Then after this, let's move on to your next question. This was question 3. D dx ln sine square 3x, right? Problem is that for 1 over, I mean, sine square 3x, I can understand this is what? If I differentiate it, it's going to be 1 over sine square 3x. And then I have to just simplify it. 1 over sine square 3x, I have to simplify that. So our differentiation of 1, so ln sine square 3x d dx. If I break this down, it's going to be 1 divided by sine square 3x. Nothing will change. 1 divided by sine square 3x. I can break down your sine square 3x as what value? Sine square 3x. I mean, I can first differentiate completely 1 divided by sine square 3x, and the next value is going to be 2 sine 3x. Right? If I differentiate this part only, that's going to be 2 sine 3x. And this is again a whole power differentiation, right? When you're differentiating just inside the power, sine square 3x, differentiation of inside the power, sine square 3x is going to be sine square 3x. That's going to be, this is actually 3 whole square, right? So you get your 2 sine power 3x, and inside the bracket, if you differentiate again, because of it is a power differentiation now, that's going to be 3 cos 3x. So you get 3 cos 3x. So I'm going to write all of this directly over here. 2 sine 3x and cos. So 3 cos 3x, right? All of this are multiplied with each other. We have this is what? This as sine 3x whole square. I can understand this sine 3x. This sine 3x cancels out. So you basically have 2 into 3 as 6 cos 3x divided by sine 3x only. Cos by sine is going to give you cot, and that's going to be 6 cot 3x, right? Because sine by cos was tan, cos by sine is going to be cot, and that's your answer. After this, now again they're asking that find this value, right? 3x square minus 4 power 6. Differentiation of this, I have to again do power factorization, chain rule differentiation. So for your chain rule differentiation, I have d by dx 3x square minus 4 power 6. For this, I'm going to get 6 3x square minus 4 power 5. And then inside the bracket, I'm going to write this as how much? 6x only, right? Minus 4 will be entirely vanished. So we get 6x only. Yeah, only 6x. That means after this again, if I multiply 6 with 6, then we get 36x and 3x power 4 minus 4 power 5. This is the only part for your part 2a. Then after this again, they're asking that you have to integrate this, and your answer should be in terms of r, where r is an integer to be found. X 3x square minus 4 power 5 root 2 and 0. 3x square minus 4 power 5. The boundaries are not important at this point. I can understand that this entire thing is exactly equals to x 3x square minus 4 power 5, right, up to this. These things are entirely equal. So if I can only, want to make them entirely equal, I just have to write that this thing is divided by, this is actually equals to your 1 by 36. Yeah, 1 by 30, 1 by 36, then, uh, 1 minute. It was 3x square minus 4 plus 6. So this is equals to 1 by 36x, this value, right? We don't have a 36 in front. But for that, we have an 36. Okay, we can consider in this way that if this is equals to 36x, this value, then this value is going to be equals to this coordinate as 1 by 36, 3x square minus 4 power 6, right? Integration of this is going to be equals to this value. And how can you consider? Because in integration, you can never integrate 36 over here. So maybe you have a 36 in this case, and that was not given as a part of your equation. So you only took that 36 to the right hand side, and now it becomes 1 over 36, the original equation. If you integrate the differentiated equation, you'll always go back to the original equation, right? That's why we integrated this equation and we went back to the original equation divided by 36. Is this clear?
Yes, ma'am.
So now we can just introduce the boundaries. The boundaries were root 2 and 0 because we actually don't know how to integrate these power values. That's why we're trying to find out similarities of part B with A. And after this integration is done, now just have to insert the values for root 2 and 0 into the equation. So we get 1 divided by 36, 3 root 2 whole square minus 4 power 6, and this is subtracted with another 1 divided by 36. Let's take that as a common, and we get 3 multiplied with 0 minus 4 power 6, right? So from the first part we have 3 root 2 square minus 4 power 6, that is actually 64, and from the second part we have minus 4 power 6, that's actually 4096 divided by 36, and that becomes 64, 4096 by 36 by 36, which is 112, negative 112. Right, so this is all the answers you need to do for your question 3. Just 1 minute. So this is it for 3. Then you can move on to question 4. Question 4 says that the function f is defined by this range of f. This is normally in what? Ax square plus c format, right? For ax square plus c, c is the value for your minimum point. This is a quadratic equation, positive quadratic equation. Your minimum point is at minus 5, right? So this is at minus 5. That means obviously range will be greater than equals to minus 5. So you get your f of x greater than equals to minus 5. Damit, if the equation was not in the format of ax square plus c, if the equation was ax square plus bx plus c, then how will you calculate the value for your range?
By using horizontal, sorry, vertical axis.
No. If the equation was given in the format of ax square plus bx plus c, that means the entire quadratic equation was given. In that case, I cannot understand that where the turning point is, right? So you have
Yeah.
to write this as completing the square format. And
Oh,
from here, I can understand that, okay, your turning point coordinates are minus B and C, right? So this capital C will be your range, right? If this is a positive quadratic equation, then your f of x was supposed to be greater than C. And if this was a negative quadratic equation, then that will be like less than equals to C. Right? This is for the minimum point, and this is for the maximum point. Just 1 minute. Just sorry. So this is how you're going to find it out then. But for this equation, they're only giving you 1 mark. You do not have to think about the computing the square or anything. Whenever the equation is given in ax squared plus c is your the coordinate for your turning point. Doesn't matter if it's maximum or minimum, right? If it's maximum, then always the range will be less than equals to, and if it's minimum, the range will be greater than equals to, right? Just 1 minute, sorry. Okay, then if we move on to your part B, the following page, there is a diagram labeled 1, and which shows a sketch of the curve of y is equals to fx. Diagram 1 shows the curve of y is equals to f inverse x. Like you have to draw the I'm sorry, as I was explaining, that you have to draw the graph for f inverse x, right? When I know that for f and f inverse x, they're going to create an image of each other over y is equals to x line. So this is your y is equals to x line. So I'm just going to create the same equation, I mean, same type of shape over this part, right? So that I'm just going to like create an image of each other over that y is equals to x shape. So the same shape will be created like this. So 1 minute. Okay, roughly this type of answer will be accepted, right? So this is how your graph for f inverse x will look. Now for this one, I didn't do any calculation. I'm just going to like first plot the line for your y is equals to x, and this is the graph for your y is equals to f inverse x, right? And then again after this y is equals to x line should be in a broken line, not in an entire solid line. So we're just going to keep it over here that this was the line for you y is equals to x, and then after creating an image of y is equals to x, we got the graph for your f inverse. This only have to be written, otherwise nothing else. That's why they're giving you 2 marks for this. Is this clear?
Yes, ma'am.
Then that's it for part B. After that, it says that the curve with the equation fx meets the curve with the equation f inverse x. Using algebra, you just have to find out the x coordinate. That means they're talking about this point, right? This is where they're intersecting, and this is what the coordinate that we have to calculate. I exactly know, obviously I can just intersect the two equations together and that will give me the value for your x, but I do not have the equation for f inverse. So I have to calculate the equation for f inverse, which is 2x squared minus 5. So you have your part C as y 2x squared minus 5, and you can write this as 2x squared as y plus 5, and then the value for your x is going to be y plus 5 divided by 2, entire thing under the square root. And again, if we want to write this, we're obviously going to write this as f inverse x is going to be x plus 5 divided by 2 square root. And now again, for that coordinate, I just have to write f of x as f prime x, which is going to be 2x squared minus 5 and x plus 5 by 2 square root. Now if you take the square to the right hand side, becomes 4x power 4, 20x squared plus 25, then x plus 5 divided by 2. Again, take that 2 to the right hand side. So we now have again 8x power 4, 40x squared plus 50 minus 5, and x equals to 0. Wait 1 minute. We have 2x squared minus 5 and then x plus 5 divided by 2 whole. Now in this situation, if I want to solve this in this way, we have a what? X power 4 equation, right? X power 4 equation is very difficult to solve. So I can just do one thing. I mean, if I want to intersect the equations, then I cannot actually solve the cubic for power 4 equation. So I can do one part over here is that if I can insert f of x into f inverse x, that will also give me a solution for this, right? So if I can consider f inverse fx, F inverse fx means, or I should write it like this, 1 minute. F inverse x. That means I'm going to insert f inverse x into fx. So we are starting with x square minus 5. And inside that x square, I'm going to write x plus 5 divided by 2. Everything was square root, and this was a square minus 5, right? All this thing is always equals to x, if you remember. F, f inverse x or f inverse fx. That is always equals to x. That means all this time, this is equals to x. That means now I can create an equation. The square and root will cancel each other out. That means this 2 and 2 cancels each other out. And no, wait, 1 minute. If that's equals to x, then also I'm not getting anything out of this, right? X plus 5 minus 5 will cancel the 5 also, and then you will be left with x only. So this doesn't solve anything. This is 0. If this is 0, 2 minus. Just 1 minute, damn it. We can also think of this in one way. 1 minute. Again, if I want to solve it in this way, right? In this way also, I get what? Just the value will be x equals to x, right? That doesn't give me anything. So this only proves that obviously that both of them are inverse of each other. But I can understand that this point P is actually the intersection of f inverse x with y is equals to x, fx with y is equals to x, or fx with f inverse x, right? All these three graphs over here intersecting together. So if I want to find out the value for P, I cannot just write this equation of fx as f inverse x. We already tried this. That eventually ends up giving you a cubic 4 equation, right? Power 4 equation. I cannot also do this one if f inverse x. That only ends up giving you the value for this equation is equals to x. We can now insert your fx equals to x, right? Because we're considering that fx equals to y. Like basically, I'm going to say that your fx is intersecting with your y is equals to x, and then we can solve the equation. So that leaves you with you that 2x squared minus 5x, and eventually you have 2x squared minus x minus 5 equals to 0. And then after this, you just have to middle term this, factorize this. I cannot factorize this, so I have to use that formula method, which gets 1 plus minus root over 1 square minus 4 1 minus 5. So this was 2, and then everything under the square root divided by 2 2, right? So this one becomes your 1 plus 20. That's basically, 8, 1 plus 40. That's 41. So you get 1 plus 41 root divided by 4 and 1 minus 41 root divided by 4. This one is a negative coordinate, and we can clearly see from the graph that P was not at the negative x coordinate. So we'll not accept this, we'll only accept this value, 1 plus 41 root over 4. Is this clear, Dhamit?
Yes, ma'am.
So then this is it for question 3. So question 4. Then if we quickly move on to your question 5. Solve this equation within 0 to pi. That means maths has to be carried out into radian. X minus 2 root 3 sec x plus 2. Okay. So x minus 2 gives you x equals to 2. And the other value is going to give you root 3 sec x plus 2 equals to 0. Now root 3 is 1 by cos, right? So from this part, if sec x gets to be minus 2 by root 3, so in that case, cos x is going to be root 3 by 2 negative, right? The entire fraction will get inverted. And after this, x will be cos inverse minus root 3 by 2. And again, you have to obviously shift your calculator first to the radian mode and then calculate it. Cos inverse minus root 3 by 2. That turns out to be 5 by 6 pi. So this is your 5 by 6 pi. I can understand that obviously this is smaller than your pi. In the next value, if I want to this is for sine. So I have to subtract this from 2 pi, right? 360 minus first value. 2 pi minus first value will obviously give you a value greater than this, I mean greater than the range. So there's no point of calculating the second and third value. So we get the values for x as 2 and 5 by 6 pi. Right? These are the only values that you're going to accept over here. That's it for part A. And then after this, we have to solve this. 10 sine theta is equals to 2 cos 2 theta. 3 cos 2 theta. I have to break down that 3 cos 2 theta in terms of sine. So for part B, 3 cos 2 theta can be written as 3 minus 6 sine squared theta, right? Because it was 1 minus 2 sine squared theta. 1 into 3 is 3, 2 into 3 is your 6 sine power sine squared theta. Just 1 minute. Okay, then after this, if I want to write, then obviously I can consider this as 6 sine squared theta plus 10 sine theta minus 3 equals to 0. And then again, after this, I just have to what? Factorize this, but I don't think we can factorize this. So we just have to write sine theta as minus 10 plus minus your 10 squared theta to 6. So you get one answer as, in decimals, let's write, then we're getting one answer as 0.138. And then the next answer would be 1.10805. So negative 1.805, right? Both of them are equals to sine theta and sine theta. 1 minute. Here the range was within 0 to 360. That means again you have to calculate your answer in degree mode. That means after this, we have to write down the value for theta as sine inverse 0.138, which is sine inverse 0.138. This is 7.93. Wait, 1 minute. Sine inverse 0.138. Yeah, we're getting one magnitude as 7.93. 1 minute. Minus 10 root plus root 10 square plus 2 into 6 into 3 divided by 12. So I made a mistake. This was supposed to be 4, right? In your equation, I wrote 2 in that place. So if you calculate this, you're going to get 0.25, actually 260. And if I carry on with the same part with the negative value, then you're going to get 1.93, negative 1.93. So then sine inverse 0.1, so 26. This is supposed to be 26, and then we get your first value as 15.1 degree. Then your second value will be 180 minus 15.1 degree. And how much is going to be your third value? Third value is 360 plus first value, which will be greater than this. So we're not going to accept that. So we're not again going to waste our time writing that. After this, we can write your value for theta as sine inverse negative 1.93. So sine inverse negative 1.93. That's so 1 minute sine inverse. Yeah, negative 1.93 is actually a greater value, right? So this will obviously not give you any value because for sine, the maximum and minimum was plus and minus 1. 1.93 is obviously greater than the maximum value. So this will give you a math error. So now going to continue there. We get 15.1 degree and your 180 minus 15.1, that's 164.9 degree. Okay, so the value of your theta is this then. That's it for question 5. Tami, is this clear? Any
Ye-
problem from 5?
No, no, ma'am. Yeah.
Okay, then if we move on to question 6, this one is functions again. Figure 2 shows a sketch of the function f of x. This is the equation, and for the vertex at point P, find the coordinates. I've always told you that for vertex, your modulus part of the equation is equals to 0, right? So if that says that part is equals to 0, then x minus 2 equals to 0. That gives you x equals to 2. For f2, we're going to calculate the equation for the y coordinate. 3, 2 minus 2 minus 10, that's just going to be minus 10. So coordinate for P turns out to be 2 minus 10, that's it. And then again ff0 means I just have to insert the values. First calculate f0, that will be 3, 0 minus 2 minus 10. This is how much? 0 minus 2 is minus 2, minus 2 with the modulus is 2, 2 with 3 is 6, 6 minus 4 minus 10 is minus 4. If I'm going to insert ff4 or ff0, that means I have actually minus 4 minus 2 minus 10. Minus 4 minus 2 is minus 6. Minus 6 with minus 6 outside the modulus is plus 6. 6 with 3 is 18. 18 minus 10 is actually 8. So this is your answer for your part B. And then again, after this, solve this inequality, this quadratic function less than the straight line, right? So we have, again, I exactly do not know that over here, if this is a positive function or negative function. So I have to do piecewise function again. So we have your equation as 3x minus 2 modulus minus 10. So it could be either 3 minus x minus 2 minus 10 or 3 plus x minus 2 minus 10, right? Both of them could be your actual f of x. So not y, f of x. And this was equals to 5x plus 10. So if I write, if I simplify and write this, it's going to be minus 3 x minus 2 minus 10 equals to 0. And then we get minus 3x plus 6 minus 10. It's not equals to 0. 5x plus 10 and then 5x plus 10. That's going to be, if you take all the x's together, we have your minus 8x and minus, sorry, 10 plus 10 minus 6, that's 20 minus 6, which is 24. So you get the value of your x as 24 by minus 8, that's going to be minus 3. Okay, then again after this, we can write this as 3x minus 2 minus 10, 5x plus 10, and that's going to be 3x minus 6 minus 10, 5x plus 10. So you can write this as 3 minus 5x and 10 plus 10 plus 6. So which is 2x minus 2x, 26. So the value for your x is going to be 26 over 2, which is again minus 13. Right, so the value for your x is minus 13 or 3. Y is equals to 5, sorry, y is equals to 5x plus 10, right? So you have your 3x minus 2. Solve this inequality. Minus 3x plus 6 minus 10, then 5x plus 10. That did give you minus 3 minus 5 minus 8, and 10 plus 10 minus 6 is 10 plus 10 minus 6. That's sorry, 10 plus 10 is 20. 20 minus 6 is actually 14, not 24. So 14 divided by 8, that gives you 7 by 3. Okay, 7 by 4 negative, and this one gives you minus 13. Now in this situation, if I'm talking about here, I mean this is actually minus 7 by 4. For the inequality I have to find out, but in this case it was stated that your f of x was less than 5x plus 10, right? The f of x was less than 5x plus 10, and from this part, if you understand, 26 minus 2, yeah, x is equals to minus 13. That means we are actually talking about this value. This is your one coordinate. This one gives you minus 13. 3x minus 6, 10, 5x. Yeah, this one again gives you minus 13. If both of them are giving you minus 13, then no, in that case, they are intersecting two times with this, right? Okay, this is how maybe the graph was actually. The graph was at 7 by 3, 7 by 4, 7 by 4 was 7 by 4 is 1.75, and then again at minus 13. That means maybe the graph was intersecting with the x-axis somewhere over here, because the graph will obviously intersect with the y-axis at positive 10, and in this case this is your one coordinate. And in general, in usual cases, if you didn't actually do modulus, right, then this graph was supposed to travel in this way. Right, and when this graph was supposed to travel in this way, and this graph was supposed to travel in this way, then what you can see, they were supposed to intersect at minus 13, right? This is your minus 13. Because for that other part of your piecewise function, when you're considering this is entirely as positive equation, then we're considering that we're also accepting your negative y-axis, right? So if I didn't do the modulus of that function, then the graphs were supposed to interact at minus 13, but we did the modulus of the function. That's why we're not going to accept this value. We're not going to accept y is equals to, so x equals to minus 13. We're going to reject that, and we're going to only accept x equals to minus 7 over 4. So this is your minus 7 over 4, right? And if I want to find out that for which regions your f of x was above your 5x plus what? 5x plus 10, right? I have to then focus on your coordinate of this value. You can understand that for f of x, like for f of x 7 by 4, right? If this is 7 by 4 negative, then I'm going to consider for which values your graph of the um, what was that? Your graph for that um, modulus function was greater than your straight line, right? So less than your straight line. Okay, that means I will erase this part. Okay, I don't want to obviously go beyond that point, but I can understand that exactly if you move to the less than of this side, then your f of x is greater than your y 5x plus 10. But as you can see, your this black line is above your red line. So for this range, x less than 7 by 4, negative 7 by 4, f of x was supposed to be greater than this value. But I'm trying to find out a region for which f of x is below the straight line. So if you move to the right hand side of your that intersecting point, then you have your y is equals to 5x plus 1 and f of x below them. So that means for this specific region, for the region of your f of x less than 5x plus 1, I have to work with your x greater than 7 by 4. Is this clear, Tami?
Yes, ma'am.
Then we are done with your part C, and again you have to write that this is not equals to 13, right? But you have to show the working for this one also. And then if I can focus on your part D, if x modulus equals to 0. X modulus means that this time only the value of your x should always be a positive, but otherwise f of x could be a negative, right? So we are again using that piecewise function. This equals to 0. So we have equation as minus 3 modulus of x minus 2 minus 10 equals to 0, right? We're using the negative of the f of x with the x modulus. So you get minus 3 modulus of x plus 6, 10, 0. That's going to be minus 4. Take that to the right hand side. It becomes what? Positive 4, right? Yeah, plus 6 minus 10 is actually 4. If we take this to the right hand side, it becomes plus 4. Minus 3. That's one value that you can get. After this, again, you can do the same procedure for your, like, positive and negative values. Minus 3, x minus 2, and minus 10 equals to 0. And that will give you minus 3x plus 6. Oh, sorry, we did that for negative already. So you're going to do this for positive. Minus 6 minus 10 equals to 0. And that will be x equals to 16 by 3. Right? So this is another equation that you can get, 16 by 3. So now over here, wait 1 minute, minus 3x, it's going to give you minus same value. Okay, just 1 minute, I'll just explain this again. In this situation, we were given the equation as f modulus of x equals to 0, right? So in this means it can, the value for your x could be negative x or the value for your x could be positive x. If that's the case, then your f modulus of x equals to 0 have to be considered as positive x minus 2 minus 10 equals to 0, and then again your f modulus of x equals to 0 as 3 negative x minus 2 minus 10 equals to 0, right? Inside that entire modulus function, we're not supposed to have plus and minus. This time only before that x, we're supposed to have plus and minus. And that will give you 3x minus 6 minus 10, 0, which is just x equals to 16 by 3. And for the next equation also, I'm going to write as minus 3x minus 6 minus 10, 0. That's going to be x equals to 16 by minus 3, right? So you get one value for x as positive and one value for x as negative. But you have to again, choose one of the data over here. That why you're going to choose plus value or not the minus value. In this case, it was already stated that solve this equation and oh wait, solve this equation equals to 0. They never mentioned anything that you're not going to accept the plus or minus, so both of them are accepted. We have 16 over 3 positive and 16 over 3 negative, so this is your answer, nothing else. Is this clear now, Tamit?
Yes, ma'am.
Then if we move on to question 7, they're asking that a scientist is studying two different populations of bacteria. The number of bacteria N in the first population is modeled by the equation NaEkt, where A and K are positive constants in the time in hours and the start of the study. Given that there are 2,500 bacteria in this population at the start of the study, that means at the start of the study when uh, N is 2,500, T is 0 hours. And then again, there were 10,000 bacteria after 8 hours. Right, that means we have to do what? Maybe do insert this information into the equation, get two equations, and then do simultaneous to get the value for your A and K to four significant figures. So first part is if I'm going to insert that N equals to 2,500 when T equals to 0. So you get 2,500 A exponential k into 0 is just going to be 0, right? So you get e power 0. In that case, e power 0 is 1. So your value for a turns out to be 2,500. Then again, the other information was n 1,000. So 10,000 when t equals to 8. That means we have 10,000 equals to 2,500, the value for your A, and then 8K. Divide this with 10,000, so we have A 8K, then again 1,000 divided by 2,500. This and this and this cancels out. 100 by 25 is just going to be 4. So you get your 8K as ln 4, right? Because exponential to the right hand side becomes ln. Finally, the value for your K is going to be 1 by 8 ln 4. So this is it for your part A. We just did inserted the value for your N and T for 2 times with the equation to get the value for A and K. The answer was supposed to be in 4 decimal place. So I have to break down this ln 4 divided by 8, that is 0.1733. So this is a value for K into 4 decimal place, 1733. Okay, that's it for part A. Now for part B, they were asking the number of bacteria in the second population is modeled with this equation. When T is equals to time in hours and the start of the study, find the rate of decrease of bacteria in this population exactly 5 hours from the start of your study. Your answer should be in 3 significant figures. For this rate of decrease, I have to work out. Rate of decrease means first I have to find an expression for your differentiation, right? dn by dt. And then only I can calculate this. Rate of decrease in this population exactly after 5 hours. Yeah. So for that, rate of change have to be calculated. For part B, dn by dt. This time the formula was 60,000 E 0.6 T. So N was here 60,000, 0.6 T, right? So in this case, if I want to first differentiate this, how much is it's going to be? I mean, N is 60,000, E to the power of negative 0.6 T. They're only giving it 2 mark, rate of decrease of bacteria in this population. I just have to differentiate this. That means we are going to have 0.6 written in front of this entire expression, and actually nothing will change. 1 2 3 4 1 2 3 4 into 6, that is 3600. So we get minus 36,000 exponential 0.6. T was 5, right? I want to find out your rate of decrease in 5 years. So you're going to write minus 36,000 into exponential and 0.6 multiplied with 5. That is going to be negative 1792. That means negative 1792 is your value. So we are supposed to keep your answer to 3 significant figures. So I'm going to write this is actually negative 1790. Right? That's your answer. Other than this, nothing else to write. Then we are done with your part 7b also. So for this, if I again move on to your part C, when T is equals to capital T, the number of bacteria in the 2 different populations are same. So find out the T to 3 significant figures. So we now know that the first equation was 2,500 e power. It was actually ln 4 by 8, right? That was the actual significant value. And in decimal, it was 0.1733. So you get 0.1733 capital T, and that is equals to your 60,000 exponential 0.6T. So if I can just, take this to the right-hand side, we get E 0.733T, and that is equals to 60,000 divided by 24, 60,000 divided by 2,500. 60,000 divided by 2,500. That's 24 here. 24 exponential 0.6 capital T. This has a negative power. That means actually this is in the fraction over here, like 24 exponential 0.6 capital T. Take this to the right hand side. So we get 0.1733T multiplied with E 0.6T 24. As we have same base with different power, so they will eventually add with each other. So we get E 0.733t, 0.6t equals to 24. That's going to be 0.1733 plus 0.6, which is 0.7733. So you get E 0.7733t, 24. Take this exponential to the right hand side, we get 0.7733t ln 24. And finally, the value for your t is going to be ln 24 over 0.7733. So you can write ln 24 as 0.7733. That's 4.109. So you get 4.11 hours, right? If I want to convert that into minute or something, no, they have only kept you answer in three significant figures and nothing else. So we'll get t equals to 4.11 hours and nothing else. Okay, that's it for question 7. Now, if I move on to question 8. For question 8, we have a function equation. The graph shows the equation for f of x. This is the graph, and we have to show that differentiation of this is going to look like this. We have to use your product rule over here, right? 2x plus 1 power 3 and e power minus 4x. So we have your f of x as 2x plus 1 power 3 e power minus 4x. For your u, we have 2x plus 1 power 3, and then your du by dx is going to be 3 2x plus 1 square. And then again after this, your value for v is e power 4x. Then dv by dx is going to be minus 4 e power minus 4x. So now after this, just use your product rule. For f inverse x, we have your u multiplied with dv dx. That's 2x plus 1 power 3 and then minus 4 e power minus 4x. And then we're going to add this with 3 2x plus 1 square with e power minus 4x, right? If I simplify this, and we basically have 4 e power 4x with 2x plus 1 power 3, and this one is going to be 3 e power 4x, and then your 2x plus 1 power 2. Right, so from there I can understand that e power 4x 2x plus 1 square is actually common, right? This part and this part is actually common in both the equation. So we're going to write e power 4x, then 2x plus 1 power 2 as a common factor, and we get minus 4. So we're supposed to get minus 4x here, right? Yeah, minus 4x here. So 1 minute, minus 4x. So we get minus 4x, and then out of this, I'm going to get plus 1. Right, so we can just directly simplify it and write it as e power 4x, 2x plus 1 whole square, and then 1 minus 4x, right? So this is your final answer then. That's it for your part A. Okay, then after this, if I move on to your, this was your part A. After this, if I move on to your part B, hence find the exact coordinates of the two stationary points on C. At stationary point, I know that your f prime x is 0. So we have to write that part B at stationary points, f prime x is equals to 0. If this is equals to 0, then your original equation that you calculated was 2. Wait 1 minute. In this part, we still have an a over here, right? And we didn't got an a in this case. We just got e power negative 4x. This is negative 4. we are supposed to differentiate the bracket of this, right? That's going to make it 6 2x plus 1 square. That means over here, instead of 3, I'm going to write 6, right? So you basically have 6 and 4. So we are supposed to take 2 also as a common factor, right? And then we're going to get that, okay, if we take 2 as a common factor, then we were supposed to get, wait, in that case, if I'm taking 2 as a common factor, 2 e power 4x, 2x plus 1 whole square. So we're supposed to get 2 divided by 2x, that's going to be 2x, and 3 divided by 2 is going to be 3. That doesn't match with your 1 minus 4x. One minute, we actually did some mistake over here. I will redo this. We have your x plus 3, x plus 1 cube with this value, so x plus 1 cube minus 4x e power 4x. So you get minus 4x 2x plus 1 power 3, and then again this value with this value. So adding this with 6, 2x plus 1 whole square, then e power 4x. Yes, so we have e power 4x, 2x plus 1 square common, and after this, if I just, take that value that, okay, 2 e power minus 4x, 2x plus 1 square as a common factor, then I'm supposed to get minus 4, 2x plus 1, right? Not exactly minus 4. 4 divided by 2 is going to give you minus 2, 2x plus 1, and then your 3. After this, you get 2x power minus 4, 2x plus 1 square. I can multiply this. We are going to have minus 4x minus 2 plus 3, and that's going to be 1 here, right? This restores your value, and this was written as 2x plus 1 square. Then this one is actually 1 minus 4x and e power minus 4x, right? This was your equation. Now if I write it down over here, 2x plus 1 square, 1 minus 4x and e power minus 4x equals to 0. That means we basically have 2 e power minus 4x, 2x plus 1 square, and 1 minus 4x equals to 0. So then again, we can write 2 e power minus 4x equals to 0. That's going to be how much? E power minus 4x equals to 0. So you get your answer of x as ln 0 minus 4. This is going to give you a math error situation. Then again, your 2x plus 1 equals to 0. And then you get the value for your x as half, negative half. And then again, you have 1 minus 4x equals to 0. So you have your equation as 1 by 4. So you have two coordinates, half and 4, negative half and 4. So you have to obviously insert this into f of x to find out the corresponding y coordinates. So for f negative half, the equation was what? 2x plus 1 power 3 e power minus 4x. So we get 2 negative half plus 1 power 3 e power 4 negative half. Right, this gives you a value of 0. And then again, if I calculate this for 1 by 4, which is 0.25, so 0.25 plus 1 power 3 e power minus 4, 0.25. That's going to be 27 by 8e. So you get 27 by 8e. And this is your coordinate. Then we have negative half and 0. And then again, we have your 1 by 4 as 27 by 8 exponential, right? So these are the coordinates for your stationary points for this graph. After this, again, if you move on to your part C, now they're saying that the function g is defined as gx is equals to 8f x minus 2. So find out the coordinates of the maximum stationary point on the curve with equation y is equals to gx. I can understand that from here, this is the minimum point and this is the maximum point, right? Because this is all obviously at a lower coordinate and this is at a higher coordinate. So this is the minimum point and this is the maximum point. Even though we didn't prove this with that double differentiation equals to 0, where I'm getting the double differentiation, positive for this one and negative for this one. I didn't prove that, but you don't need to prove that. You just do not need to do translation for your 8C over here. For part C, we understand the maximum point was 1 by 4, 27 by 8e, and your translation was 8x minus 2, right? Yes, 8x minus 2. So we are working with that. Okay, f of x after translation become 8 f x minus 2. That means whatever the xy coordinate of f of x was, that will be um, x plus 2 and 8y, right? X minus 2 indicates horizontal translation, horizontal stretching. So horizontal translation of 2 unit, and this is vertical stretching of 8 units. So if your coordinate was 1 by 4, 27 by 8e, then this will be converted to 1 by 4 plus 2. That's going to be 0.25 plus 2. That's 9 by 4. So you get 1 by 4 plus 2. That's 9 by 4. And your other value was 827 by 8e. So 8 cancels out. So you get 27 by exponential, right? So this is the coordinate for your gx. Right, we calculated that using the translation process. Okay, then this is it for question 8. Now we'll quickly move on to question 9. We actually have 10 questions in this paper. So you're done with 8. Then for question 9, they have given you one quadratic function, cos 2x sin x and sin 2x cos x is equals to cos x. You have to prove that. Cos 2x by sin x and sin 2x by cos x. Okay, first I can obviously break down your cos 2x as 1 minus 2 sine square x. So 1 minus 2 sine square x divided by your sine x, and this will be added with your sine 2x. Sine 2x can be written as 2 sine x and cos x divided by cos x. Obviously, from this part, cos x cancels out, and you are left out with 1 minus 2 sine square x by sine x plus 2 sine x. Right. After this, what can you do here is that again we can break down this part and write it like this: 1 by sine x, 2 sine square x, sine x, and your 2 sine x. Again, in this part, sine square x, sine x can be cancelled out, leaving you with 1 by sine x, 2 sine x, plus 2 sine x. Right, so obviously then again what? Sine x cancels out, 2 sine x plus sine x cancels out. You're left out with 1 by sine x, which is actually your cosec x. Right, this is what we're supposed to prove here, cosec x. So we're done with this. Part A is clear. Then after this, we can see that within the range of pi by 2 and 0, we have to solve this equation. Answer should be in 3 decimal place. 6 cot x minus 4. Like I already know that cos 2x by sine, sine 2x by cos is actually your cosec x, right? So we basically have to write cosec x equals to 6 cot x, cot theta minus 4. We can directly write that your cosec theta is your 6 cot theta minus 4. Now cosec is what? Cosec is 1 by sine and cot is sine by cos. Sorry, cot is cos by sine. Hmm. So we have the left hand side entirely under a square. So we're getting cosec square is equals to 6 cotec cot theta minus 4. The cosec square can be written as 1 plus cot square. So we get 1 plus cot square 6 cot theta minus 4, and from there I can write okay cot square theta minus 6 cot theta, and 1 plus 4 is going to be plus 5 0, right? That's it. Now if I want to split this, 1 minus 6 plus 5. That's going to be what value? 1515, right? Yeah, I mean, I can split this over 1 and 5, 1 and 5. So we can write your answer as cot squared theta 5 cot theta, and then cot theta plus 5, 0. From this part, we can write cot theta 1 minus 5, sorry, cot theta minus 5. So we can write cot theta minus 1. So we can write this as theta, I mean, cot theta equals to 1. So you basically have your tan theta also 1, right? And this one is going to be cot theta 5. So your tan theta from this will be 1 by 5. So finally again theta becomes tan inverse 1, and theta becomes tan inverse 1 by 5. So you can write your answer as, answer should be in 1 minute. In radians within the range of 0 and 90, 0 and half pi. So obviously convert your calculator into radian mode, and then you get tan inverse 1, which is pi by 4. Obviously this will be accepted, but the next value, pi plus first value, that will be greater than the range. So we cannot accept that. And for the other part, we're going to get tan inverse 1 by 5. That gives you 0.197, right? 0.197. And then again, if I'm going to add this with pi, that will be also greater than my range. So these are only values of theta that I'm going to accept, and no second value for this one. It's just pi by 4 and 0.197. And then after this, we're done with part B also. Now they're saying that integrate this within the range of pi by 4 and pi by 6. I already know that over here, your cos 2x, sin 2x, cos x is actually cosec x, right? So if I want to cosec x, right? So we have cosec x, cot x. We just have to integrate this. That's going to be what? Negative cosec x. That's why they're giving you 2 marks. We have your cos 2x, and pi by 6. If we integrate this entire part, this is actually what? Cosec x, cot x, right? So if we integrate this, we're going to get negative cosec x with the boundary of pi by 4 and pi by 6. This portion was your cosec x from part 1 we calculated. So integration of cosec x, cot x is negative cos x. So we get minus cosec pi by 4, and we're going to add this with cosec pi by 6, right? So that will give you the value, which is going to be 1 minute. How will you calculate this? You'll calculate this as 1 by sine, right? So you actually have 1 by sine pi by 4 and 1 by sine pi by 6. So you get your answer as 1 by sine pi by 6. That's just 2 minus root 2. 2 minus root 2. Let me see if they asked you answer exact values. You're supposed to keep your answer in the surds format. That's 2 minus root 2. Okay, then we are done with your question 9. Then after this, if you're going to move on to your question 10 of this paper, this is again shows a sketch of the curve with function this value. Find dx by dy in your and your answer should be like in a simplified format. Okay, for this one, I have to use the quotient rule. For this one, we have in part A, u is 2y square plus 6. So du by dx is going to be 12y, just that. v is 3y minus 3, so dv by dy, not x actually, y is going to be 3 only. So you get your dx by dy, that's going to be 12y, 3y minus 3 minus 3 2y square plus 6. And then after this, you have your how much? 12 into 3 is actually 24, right? Yeah. So we get this as 24y square minus 24. 12 into 3 is not 24, so 12 into 3 is 36. And then your next answer is going to be 6y square minus 18. We are supposed to find out dy by dx, right? So we have, sorry, made a mistake. This is supposed to be 4y, not 12, and 3. So that's 4y. So you get 12y square minus 12, and then again minus 6y square minus 18, right? 6, 20, 6 is 18. 3y minus 3 whole square. After this again, you get how much? 12 minus 6 is just going to be 6y square. This is going to be 12y, 2y square plus 6, and 3y minus 3. So you get your 4y, and then 3y minus 3 is going to be 3. So this 2 is here, and this 2 is here. So 4y with 3, that's 12y square and 12y. And 3 with 2 is 6, and 3 with 6 is 18. Yes, so we get your answer as actually this value. So we are going to write your answer as 12y square minus 18, sorry, minus 12y minus 18. And then after this, so this is going to be 6, right? 12 minus 6 is 6. And in the denominator, we have 3 minus 3 whole square. So if I take 3 as a common factor, 3 minus 3y minus 1, and everything over here was a power of 2. That means in the denominator, I can actually write 9y minus 1 whole square. And from the numerator, I can take 3 as a common factor. If I can take 3 as a common factor from the numerator, we have your 2y square minus 4y minus 6 divided by 9y minus 1 whole square. So this and this cancels out, leaving you with your 2y square minus 4y minus 6 divided by y minus 1 whole square. Right? I just matched with the answer. Over here in part A, they clearly stated that your answer should be like this. So like, writing it over here in this format. Okay, then this is the value for your dx by dy. After this, now they're saying that the tangents of P and Q on the curve is parallel to the y-axis. So use your answer A to find the equations of the tangent. Okay. Now for the equations of the tangent, I always have to work with dy by dx, not dx by dy, right? So in that case, I have to calculate your dx by, so dy by dx, but then again, the tangents at point P and Q on the graph, on the curve is parallel to y-axis as shown. So use your answer to part A to find an equation of these two graphs, of these two tangents. So if they are parallel to y-axis, that means their gradient are all parallel to y-axis. Their tangents are normal, so we have the coordinate for dy by dx. This one over here are parallel to y-axis. That means what? Parallel to y-axis means your tangent at point P, you were supposed to be entirely vertical, right? Exactly vertical, and this is also exactly vertical, right? So they will have the equation as x equals to P and x equals to q only, nothing else on the y-axis, because these lines, these tangents, are going to be entirely vertical lines. So if I'm going to consider this tangent an entirely vertical line, then at point P and Q, I can again see that these 2 points are the turning points also, right? So if at the turning point I'm working with, so it really doesn't matter if you're working with dy by dx or dx by dy. The formula will always be equals to 0, right? A turning point. A turning point, it's always equals to 0. So if it's always equals to 0, I can find out the y coordinate. This is how I'll calculate. For part B, for point P and Q, we're going to write dx by dy equals to 0. So the denominator is 0. We're going to left out with 2y square minus 4y minus 6, 0. And from there again, I can make 2 as a common factor. So we get y square minus 2y minus 3. From this part, if I middle term this, factorize this, I'm going to get the values for y as 3 and minus 1. If the value for y and 3 is y is 3 and minus 1, then f3 I have to calculate, which is going to be your 2y square, 1 square plus 6 divided by your 3y minus 3. That's going to be 2 plus 6 is 8, and then 3 minus 3 is 0. So 3 minus 3 is 0, right? There's a mistake. Then I'm not getting anything from this part. This is 0. But if I write 2, 3, oh sorry, this was actually minus 1. But then it will not be 0. In that case, we have what? Minus 3 is 6. So you have 4 by 6. So that's 4 by 6 negative. That's going to be, so 8 by 6. That's going to be 4 by 3 negative. And then again, if I insert 3 into the equation, so we can write x equals to, this is not f of x, this was actually x equals to 2, 3 square plus 6, and then again 3, 3 minus 3. So that's going to be 9. 9 into 2 is 18. 18 plus 6 is how much? 18 plus 6 is 24 divided by 6. 9 minus 3 is 6. So 24 divided by 6 is going to give you 4. So I can clearly see that Q was at a positive coordinate and P was at a negative coordinate. That means obviously the equation for P was supposed to be minus 4 by 3, and equation for X is X equals to 4 by 3, and for Q it's X equals to 4, right? These are the tangents at point P and Q for the graph. So this is it. We are done with your June 2023. Right, I hope that was clear for everyone. This is the June 2023 paper. This was part B, A, then C, B, A. This was question 8 and 7, right? Okay, so we're done with this paper. Thank you for watching.